ZDepth can also be really useful for atmospheric effects. Unfortunately, ZDepth is not available for clouds directly, but I'm going to show you how you can create your own ZDepth for cloud layers very quickly and very easily. So first we need to add some clouds to the scene. I just have a basic sky right now, just kind of the default, slightly modified, just a ground plane in the scene. I'm going to go up to Atmosphere and Atmosphere Editor, or you can hit F4 on the keyboard. Either will work. And I'm going to add in a couple of cloud layers. I'm using the clouds from the XalFX Spectral version 2 collection, low altitude clouds, the low altitude collection. And I'm going to use some of these clouds, some cumulus layers, and also some stratus. And we want some nice variation between the different clouds, different height levels, and that way you can really see how everything is going to look. And we'll also be able to do this for 360-degree views as well. I'll just go ahead and increase the cover on this one. And I'm going to add in one more stratus layer. Okay, and now I can do just a quick preview. So by looking at this preview, just a preview quality render, we can see all the nice clouds, different heights, a lot of different layers kind of intersecting with each other, going up and down. So a lot of nice variation. Now, unfortunately, like I was saying, there is no ZDepth output. The only output we have for clouds is a cloud mask as of version 7.5. If you're using previous versions, then that option is not available. Although the technique I'm going to show you can also be used in previous versions of Vue in order to create your own cloud mask, which is probably going to end up looking a little bit better than the cloud mask that's put out from Vue, just because the edges tend to look like a preview render, where they're very speckled. Not really the best of control, considering the way the edges will look. But what we're going to do with this scene is first we have to save it. Saving is really important because we're going to be pretty much destroying the current cloud settings in order to get this to work, and also removing elements of the atmosphere. This technique will also work above the clouds, which we'll take a look at. But first, let's just render out a Z pass, looking at the depth of the current camera view and the current camera perspective. I might go ahead and just lift the camera up a little bit higher, just so we can see more of the sky and get rid of that horizon showing up. It really won't affect anything whether the horizon's there or not, but just so we can see more of the clouds. So first, I'm going to go ahead and just save this. And now I'm going to make some modifications to the scene. If we take a look in the front view, we can see all of the different cloud layers and the ones that are intersecting with each other. It looks like actually maybe in this case there might not be any. I ended up with 4 cloud layers. I did end up deleting one of them. Let's go ahead and just take cumulus number 3, which is our second from the top. If you're not familiar with the way the cloud layers system works within Vue, basically it will automatically stack the cloud layers and display them based on their altitude. I also want to note that when you save a cloud layer, for you to save the material, it's going to save as a mat file, which is a material file. Now, for the most part, the information you have stored for altitude and height, cover, things like that will carry over. But when you have multiple clouds in the scene already, and you go to add in one you've designed to be a certain altitude or height, it will modify that. If I go ahead and if I was to add in a new cloud layer, and then what I did with my collection, the low altitude collection, is I added in the altitude, the height, and the density, uh, some of the primary elements of each of the layers and what they were designed to be at. Now, if there are no other clouds in the scene and you load it in, those are the exact values you will get, provided using the settings internal unit, display unit of 0.1 meters. But once you have multiple clouds or other layers in the scene, it starts to modify those values and they don't carry over, unfortunately. So you can either match those settings and change them, or basically you have to use kind of a single layer, kind of copy the material. So let's go ahead and just create a little bit of an intersection here, where we're going to be inside of that stratus layer, and it does look like it's not completely intersecting correctly, probably because it just swapped the layer and I selected the wrong one. But we'll start to see them darkening, increasing the shade as they overlap each other. So now this is going to end up looking a little bit different than that preview I just showed you before, but it'll still work the same. So now we're just going to have that one layer down a little bit further intersecting, which might even cut out that top layer. Not really going to matter either way. If we're not seeing it in the scene, then we don't need to have depth for it. But this will work for any atmospheric settings, any current scene you have. So what we're going to do is start out by going to the atmosphere editor, since we have the scene saved. And what I want to do is go to the Sky, Fog, and Haze tab. Remove all haze from the scene. Haze, ground density, 0, mean altitude, 0. And you're going to see that's going to create a fairly interesting look, very bright scene, but all of that's going to be gone once these modifications are made. Aerial perspective we want to turn down to 0. Aerial perspective is the thickness of the atmosphere. It will essentially cut out cloud layers that are really high up in the scene, depending on the value that is set. By default, the value of 1 is going to be the most realistic of atmospheric density. I had mine set to 10. I like to, basically embellish on some of the atmospheric effects and use aerial perspective sometimes instead of the haze or some of the other effects to modify the atmosphere. But overall, that should be fine. One thing we need to take a look at is basically how high do the clouds climb into the sky. Now we could either take a look at the altitude of the highest layer, which is 1 kilometer, and add the height, because the altitude is going to be the starting point, and then the height is how much it climbs beyond that. So we have approximately 1.22, around 1.3 kilometers in height. So what I want to do is set the fog altitude, the mean altitude, to be higher than that. It doesn't have to be double, but it can be close. In this case, I want to set it to 2 kilometers. I'm also going to modify the fog color and make it black. And if we go to the fog ground density, I'm going to go ahead and increase that up to 100%. And we're slowly starting to get closer to where we need to be. There's still a few more modifications though. Because we don't need the amount of lighting detail that we would normally get from a color pass. We can take the quality boost setting and crank it and bring it all the way down to -4, which is how much the slider allows the negative. And what that is going to do is really increase render speed, just by a ridiculous amount. Since we don't need a lot of that detail for this type of a render from the different lighting effects, we can really turn it down and create a ZDepth pass very quickly. Now we do need to modify each of the cloud layers, but first one thing I want to do, I'm just going to click OK, and the sunlight I'm going to turn off. And what that's going to result in is a completely black scene, because there's no light. And what we're going to be using is a different light, and creating basically an inverted Z-depth. So the only thing that needs to be done is in post, just invert it. Invert the image so that instead of the sky being black in the back, it is white, and the things that are closer to the camera will be black rather than white, which is how we're going to have to generate this Z-depth. Now, before I go ahead and modify the cloud settings, I want to have a light in the scene just so you can kind of see what's happening to the clouds as I go through this process. But what I want to do is go over to the left and add in not a directional light, but we want to use just a spotlight. And what we can do is move this right by the camera, making sure the direction is from the camera. And the position I'm going to set up right now, or the rotation, will need to be changed if you're doing 360-degree panoramic view. But since we're just focusing on this smaller area, we can easily just restrict it, set it up a little bit different. So what I'm going to do is rotate the light, and I'm using the gizmo and the different rotation gizmo that we have. If you're not seeing that, if you're not using gizmos, you can go up to Display, Gizmo, Show Gizmos, and right now the rotation option, if you look at the right, there's basically position, rotation, and scale. And on the left we have the parent coordinate, local, global, and the view coordinate based on the viewport. Let's switch that to global, go to rotation, and I just want to actually go ahead and move this first and move it just behind the camera. And the rotation, if we take a look at where the center is, I want to line up the pivot to be directly behind the camera. And we could set up a meta node for this or a graph, but for the most part, it's really just going to be quicker to set this up and do it manually. If this becomes a technique you're going to be using frequently, then I would highly suggest using a graph and saving on a meta node. But what I want to do is modify the light so that the highest part of the spotlight and the brightest part, which would be the center, is going to be slightly above the camera view. And that's going to be this center line here. We just want to make sure is above the view line that we're seeing for the camera. So make this full screen, which I did just by double clicking on the top bar that lists the title. So we can see this center point, which is going to be the brightest area of the light, and we just want to make sure that that line is above this other line. And we're going to be making some other modifications too, paying attention to the cone angle. Let's go ahead and set up the rotation of this light as well. So now we're within bounds, and we can see the lines are matching up really well. So if we go to the Aspect tab and the light settings, what I want to do is increase the spread to a fairly large amount. We're going to bring it up. Let's go ahead and do 80%. I also want to remove all fall off. We don't want any sort of gradients showing up around the edges of the light because that's going to throw off our Z-depth and it's going to create something that's inaccurate. The power we do need to increase to a very high amount. Before we do so, we need to make sure it is affecting the spectral clouds. So there is a middle button here, which is Influence Spectral Clouds. We can check that on, and now the light will start to affect the cloud layers in the scene. We're going to go to our power setting and bring this up to a value of 6,000. And now we're going to start to see all the clouds being lit and showing up a lot closer to the depth pass that we are going to need to see based on the distance of the highest point of light to the cloud. Now, there are also some modifications we need to make to these clouds because they're just not showing up correctly. We have shadows, which we don't want. We don't want any shadows being cast or any self-shadowing, so we'll be modifying those options as well. But you can already see the different levels and different cloud layers, and the Z-depth is already starting to kind of show up. I'm going to move that camera up, like I said I was going to before, just above the horizon, which means we also need to take the light and just kind of pitch it up. The main thing is you want to make sure that the bottom in this cone, basically the spread angle, is not showing up within the view, because you can take a look in the tiny preview. I'll go ahead and render the main view. We can see that no light is showing up on those part of the clouds. So you do want to make sure that that is extending to the end of the cloud layers and all the way to the horizon, just making sure that is not showing up. And if we go back to the atmosphere editor, under the light tab, we can just set this to the standard lighting model. There's no need to have global ambience or occlusion, illumination, radiosity, and for the most part, those really don't affect the cloud layers anyway. I am going to apply the settings to all lights so that it is influencing cloud layers. Take our light balance and turn it all the way to sunlight, which basically is a direct lighting for diffusion, no ambient light whatsoever. And the ambient light is going to be uniform, so we don't want it coming from the sky, we want it coming from basically nowhere in this case. So we're just going to have a nice direct light showing up the brightest areas towards the camera, and all of that being created by that spotlight. So the sunlight in this case is the spotlight, because it's the only light in the scene showing up. Now I also want to just click on the icon for the ground, and if you missed that before, probably should have mentioned that you can turn lights on and off just by clicking on their icon in the layer view. So we could turn the sunlight back on just by clicking on the little icon that represents that distant light. So now we need to take care of the shadows that we're seeing showing up still, which means we need to modify each of the cloud layers. This is another reason why you really need to make sure you have this scene saved first, and a version for the color, and then when you want to create your Z-depth, you have a separate scene. It's really important to separate these, otherwise getting back to the state you were in before is really not worth it if you could have just saved. So now we can increase render speed and finish up our Z-depth by modifying each of the cloud layers. So what we need to start out by doing is right-clicking on each cloud layer, the preview, edit the material, and under the lighting and effects tab, we are going to turn off internal shadows under the lighting and turn off GI ambient lighting, which I have turned on. Basically turn all of the options off. Make sure nothing is checked. Don't change the volumetric layer lighting model, because then you will lose the shape of your cloud and the Z-depth won't match. I'm also going to turn off receive shadow on this layer. Click OK. And then Actually, there is one last thing we need to change. Go back, edit material. Under color and density, the volumetric color I want to set to a medium gray, which is going to be approximately 128 on the R, G, and B. So for red, green, and blue, 128, 127 also works, medium color. Since the overall value is 255, you can really go either way. And now we need to adjust the way the lighting is. We don't want any transparency showing up. We just want the shape of the cloud and the influence of the light against it. So that means what we need to do is increase the density amount to 100%. And I'm also going to change the opacity to 100. And if we move all the way down to ambient lighting, I'm also going to set that to 100%. Since we have no shadows, we don't have to worry about that. And I'm just going to go ahead and do that for all of these layers. Density, opacity, ambient light. And then we'll go in and modify those materials as well. And turn off shadows. And any other options that would affect the scene. Volumetric color, set that to 128. And these next ones, I'm just going to copy this color over. One thing you could do is drag the color into your favorite section. You can also edit your favorites. Basically, just a nice little swatch panel. You can increase the amount of columns, how big you want your overall stored colors to be. Either drag that over, or you can right-click, copy the color, and then paste it onto the other layers. Lighting and effects, turn off all options. Turn off receive shadows, click OK. And I'll just go ahead and do that for the other layers as well. Paste that color in and turn off any of these conflicting options. And one last one, paste the color and turn off all the options. Just want to make sure got that receive shadow on the other layer, and I did. So now let's take a look at a preview. We can see it's rendering very quickly. And we now have a working ZDepth pass of our clouds. All the clouds that are closer to the camera are going to be lighter. If you need to adjust the power of the light so that it is less intense, you can just go ahead and decrease the overall amount. I have it set to, like I was saying, 6,000, which might be a little too high. So if you need to, you can reduce that color. Since we have a nice gray medium color for the clouds, it allows us to really brighten up and have a nice transition gradient to the back of the scene where it's going to be black. If any parts of the sky are showing through the clouds, they will be black, which is why this is an inverted ZDepth as opposed to the normal ZDepth passes of view. But this, we have a very quick render. There's no need to use any render settings higher than the final pass. Without the final pass, you can't use gbuffer or multipass in case you want to save out the cloud mask, which you can do by enabling the multipass, and you can see the cloud mask option. Now, there are not individual masks for each cloud layer. It is one universal mask for all of them. So you would have to turn off a cloud layer, render, and then do that for basically every single layer if you wanted a mask for specific cloud layers. I'm going to go ahead and set this to final, render to screen. Just do an 800 by 600. But first, because we have a little bit too much intensity on that first cloud, the one that's closest to the camera, I'm going to take the spotlight and just kind of tilt it up a little, making sure that that cone angle isn't showing up. We can also rotate this and get it to point straight out from the camera. And if we need to reduce the power, and go ahead and just take a look. And there is really only one last setting that needs to be changed in the atmosphere editor, and that's basically light scattering. As of 7.5, there is a new option to scatter lights separately on the clouds than you would on the rest of the scene. Basically, it's the dispersion, collection of light around the light source and how it disperses, in this case, through the clouds. And we want a very direct effect, something that is going to be not rounded, nothing that's going to really collect around the light. We just want it to be nice and straight, flat pass. If you do want a little more curvature, you can adjust the setting. So I'm going to go ahead and just cancel this rudder and show you that. Go to the atmosphere editor, and under sky, fog, and haze, we have the cloud option, which is now separate from just the regular scattering. And a value of 1 is going to be no dispersion of light, or an equal dispersion of light, I should say, rather than collecting around the center cone source. If we were to reduce the amount, we're going to start to see the edges of the cloud start to, or the edges of the scene darken up a bit, and we're going to get different types of lighting effects. So if you want to be a little more precise about your Z-depth, obviously, in this case, turning it down to -1 is going to make the scene a little too bright. But you can adjust the scattering if you wanted to maybe fake a little bit of depth within there. For the most part, that's really not needed. A value of 1 is going to work the best. If you're not using version 7.5, then just take the scattering, bring it up to 1, and that should be good enough for the scene. Aerial perspective I'm going to set to 0. Although it looks like a value of 0.1 is all it's really letting me do. I'm going to try 0.1. See what happens, and it goes back to 0.1. So 0.1 is going to be the lowest amount of aerial perspective. Just as long as we have fog color set. If I go ahead and, just to show you what would happen, and change this to 500 meters, maybe a little lower, we'll do 50 meters. We may not see as much contrast. If I turn off the fog completely, it's not having too much of an impact on the scene, but that's mainly because we have cloud layers covering just about everything. I just like it as a failsafe, just in case there's any light patches that aren't completely covered, and that way we can have that on. I am just going to check and see if I can bring that quality boost lower than 4. So we'll go ahead and try it at -8 and see how quickly it renders. You will notice a little more noise the lower that quality boost goes. So if you need to have a very precise definition around the edges of clouds, you will need to increase the quality boost. But for the most part, Z-depth, I mean, for the most, we have the depth we need, and the really, really fine details won't matter as much as pulling them out of the color. Any sort of direct intersection with the cloud you would really want to do with a mask anyway, although the Z-depth can also be used, especially in combination with a mask. The lower you bring down the quality boost, the faster it will render, but you are going to notice a lot more noise. We can see a lot of noise around the edges of the cloud, so we might need to adjust that amount. And really, there will become a point where it doesn't really matter if you bring it down any lower, it's pretty much going to look the same. Let's go ahead and try -20. And for the most part, the render speed could stay the same. And it could be something you just want to play around with. If not, slider value, default negative of 4, works pretty good. And still produces something that looks good, that's quick. You do want to make sure that you don't have God rays on, and that you're not using any shadow options. If you're using version 7 or version 6, then all you really have is the volumetric sunlight option, which I believe is checkbox. As of version 7.5, there is the new projected shadows on cloud option. Make sure that is off. Although since all the shadows are off on each of our cloud layers, that shouldn't really matter. Also volumetric sunlight, there's no point in having that. It's just going to increase render speed for no reason. Or, sorry, decrease render speed for really not having an effect on the scene. So using no shadows on clouds works perfectly. Because the sunlight itself is off, there's nothing controlling the sky color, nor the decay, and most of these settings, except for the cloud scattering, really don't matter, so you don't have to worry about that. If I go ahead and switch this over to ambient really quick, you can see that everything pretty much disappears because we're lighting the scene entirely with this spotlight. So another way we could reduce the intensity of the light if we found we have some nice cloud definition with the current light setting, we can take the light balance and just reduce it from sunlight to ambient, which is basically just going to take it from the highest point down to black. So that's another way to just kind of tone it down a bit if you need to. Now, like I was saying before, if you do need to increase the quality boost to get some better definition, there's no need to go any higher than -1 in this case. The new default as of 7.5 is -1. And if we take a look, we're going to see a lot less of the speckling and graininess around the edges of the clouds. So if the edge detail up front is just way too grainy, doesn't look right, not enough definition, then you can just turn that quality boost up. I'd suggest anywhere between -2 to -1 works pretty well. I mean, if you need to go a little higher, bringing it up to 0 is really the highest you'd want to go, because anything higher than that is going to drastically increase render times, and you're not going to get that much extra detail out of it, and especially with ZDepth, compared to the typical ZDepth of the scene, which is these choppy in-between intersections. In comparison, this is already worlds better, having a nice gradient with absolute depth. Works really well. So there shouldn't be any need to get anything more than that. If not, for the best cloud definition around the edges, instead use a cloud mask. Disable the rest of the layers, just get the one that is really showing up in front, render that out, keep that cloud mask, and you can use that to adjust the definition or modify the ZDepth that's rendering. So there's a lot you can do to really tweak and customize it. But we can see this is taking a lot longer, and the quality isn't that much better. At least not with this sort of a setup. So we're going to bring it down to -4. Now let's take a look at how we can do this for a spherical render. Because right now, it's not really set up for a panoramic. There are a few changes, and you can even use this setting to do this type of a render if you're going to be moving the camera around a lot. This I just had a fixed camera set up, so there really was no need to change the light. But if you want something a little more versatile, take the spread and change it to 90 degrees. If we go to the rotation options, pitch at 0, roll to 360, and the yaw doesn't really matter because that's going to not make a difference unless you have a light gel, which in this case you wouldn't. So what you do is just place this directly under the camera. So now it's projecting, take a look at the local value, the Z pointing straight up at the clouds. So now we're going to have a really nice situation for creating a 360-degree panoramic. We'll select the main camera, and I want to change the pitch to 90, and that way we don't have any curvature of the horizon. We just want something nice and straight, this nice spherical map. And I'm going to set the yaw to 90, so we're pointing directly uh, along the x-axis. And that'll make it easier if we're going to be matching this to an HDRI, so we could render the color and also do this ZDepth setup to take an HDRI image, and then if we were to use that in the scene, we could also, in post and compositing, use our ZDepth. That will match up perfectly. Let's take a look at the render settings. Just right-clicking on the camera icon, set it to panoramic, spherical render. Now, as of, once again, 7.5, a new change where the spherical renders look loads better. They actually are correct. Where there's the right amount of twisting and distortion to make a spherical map, rather than just rendering the space that's available. It does distort it correctly to make a spherical map. If you are using previous versions, then you'll have to use the File and Export Sky option. What you can do is set this to a UV sphere, and then set the file name and also the format, keeping in mind that you want to use a 32 or 16-bit image. 32-bit is definitely suggested. Any graininess that you might see in the 8-bit typically doesn't show up within the 32 because the contrast is such a broad range. You can adjust the size of the texture map, but I do want to note that this only will use one core of the processor to export, which is why it's better just to render directly out of the regular renderer than using the Export Sky option, because only having the ability to use one core of your processor is kind of restrictive for time. So we'll just use 1200 by 600, and we'll render it to screen. And we can see this rendering out fairly quickly. Now, if you note along the top, even though that will be severely brought down and distorted, because that is the top of the sphere, most of it will be condensed, so that really bright white light might not be an issue. And in a higher bit depth mode, it might be okay. But if you need to, you can adjust either the transition between sunlight and ambient within the atmosphere editor under the light tab, or reduce the power of the spotlight. Keep in mind once again that you have absolutely no fall offset.